Space is vast, unimaginably vast, cold, and mostly silent. Out there, hurtling further from home than any human-made object, travels Voyager 1, a tiny speck against the cosmic ocean. For months, a worrying quiet. Had we lost it? Then a signal. Faint, but unmistakable. A whisper across 24 billion kilometers of emptiness. Voyager 1 was speaking. It had something new to tell us. Something astonishing, from the very edge of our solar system. Its long silence was broken. A new chapter begins. Its initial purpose was breathtaking, a grand tour, using planetary alignments, a gravitational slingshot, Jupiter first, the king of planets, its swirling great red spot. Voyager 1 arrived. It unveiled wonders. It discovered Jupiter's faint rings, active volcanoes on its moon Io. The sheer scale of the Jovian system was laid bare. Data poured back, transforming our understanding. This was exploration at its most raw, its most thrilling. A new window opened onto our cosmic neighborhood. Then, Saturn, the jewel of the solar system, its magnificent rings, a spectacle unlike any other. Voyager 1 flew through the ring plane, a daring maneuver. It studied the intricate structure, the shepherd moons. It gave us close-ups of Titan, its thick, hazy atmosphere, a world with liquid methane seas, intriguing, mysterious. Communicating with Voyager 1 is an immense challenge. Imagine shouting across a continent, then multiply that, 24 billion kilometers. Light itself takes over 22 hours. One way, a round trip for a command and its acknowledgement, 2 days. The signals are incredibly faint, weaker than a watch battery. Yet, NASA's Deep Space Network, giant radio antennas. They listen, patiently, straining to hear those whispers. For decades, this fragile link has held. A triumph of engineering, a testament to the power of radio waves and human persistence. Recently, that link faltered. The whispers stopped. Voyager 1 fell silent, not completely. It was still transmitting a carrier signal. But the data, the precious science, it was garbled, unusable. A problem deep within its flight data system, its digital brain. The team at NASA's Jet Propulsion Laboratory faced a daunting task. How do you fix a computer nearly 50 years old, one that is billions of miles away, with outdated documentation? Fear grew. Was this the end of Voyager 1's historic mission? The silence from the void was heavy, full of uncertainty. The edge of everything, peering into the Oort Cloud's veil. So, what new message did Voyager 1 bring? It seems to concern the Oort Cloud, a truly enigmatic region. Imagine a vast spherical shell surrounding our entire solar system, stretching out almost a light year into space. Immense. This is the Oort Cloud, named after the astronomer Jan Oort. He theorized its existence decades ago. It is thought to be made of trillions of icy bodies, comet-like objects, frozen remnants from the solar system's birth, a cosmic freezer, holding clues to our origins. This distant realm is the birthplace of long-period comets, those spectacular visitors from the outer darkness. Occasionally a gravitational nudge from a passing star, or a galactic tide, sends one of these icy bodies inwards, towards the sun, where it warms, and sprouts a magnificent tail. The Oort Cloud is a reservoir of primordial material, largely unchanged since the solar system first formed. Studying it is like looking back in time, 4.5 billion years, but it is so far away, so faint, so difficult to observe. Until now, its existence has been mostly inferred, from the orbits of those long-period comets, their paths traced back, pointing to this distant spherical nursery. We have never directly seen the Oort Cloud in detail. No telescope can resolve its individual objects. They are too small, too dark. It remains one of the last unexplored frontiers of our solar system, a ghostly halo, shrouding us from the true interstellar void. The astonishing revelation: new light from the solar frontier. The data, now flowing cleanly, contains something new. Subtle changes, anomalies in the particle readings, the magnetic fields. These are not the smooth, expected conditions of interstellar space, nor are they the familiar environment of the outer heliosphere. Something is different out there, where Voyager 1 now roams. The scientists are cautious. This is cutting-edge research. But the patterns are intriguing. They suggest structure. Could Voyager 1 be detecting the first true signature, the tangible presence of the inner Oort Cloud itself? The initial findings hint at unexpected characteristics. Perhaps the density of icy bodies is higher than predicted in this region, or maybe their composition is different from what we thought. Are there more volatile ices, or different types of dust grains? Some readings suggest variations in the plasma environment, interactions between the interstellar wind and Oort Cloud objects. these are just preliminary interpretations. Much analysis is needed, but the possibility is electrifying. A direct encounter. Voyager 1 may be painting the first strokes of a new cosmic map. If these findings are confirmed, the implications are profound. Resilient explorer, tireless minds, humanity's enduring spirit. Let us pause and consider Voyager 1 itself. A machine, launched in 1977, built with slide rules and early computers. Its main computer has less memory than your smartphone key fob, yet it has survived, it has adapted, it has triumphed. Against the unforgiving vacuum of space, against dwindling power, its plutonium power source decays, providing less energy each year. Instruments have been switched off, one by one, to save power, but its core mission, to explore and report, that continues. This resilience is almost beyond belief, a true space warrior. Think of the environment it endures. Extreme cold, far from the sun's warmth, temperatures hundreds of degrees below freezing, bombarded by high-energy cosmic rays, tiny bullets from distant supernovae. Yet its electronics, designed for a much shorter life, keep working. Its tape recorder, a vintage piece of technology, still stores data. The never-ending journey, our unfolding cosmic quest. This potential discovery from the Oort Cloud, it is a milestone. If confirmed, it will add another glorious chapter to Voyager's saga. But science is a journey, not a destination. This new information will not be an endpoint, it will be a beginning, sparking new questions, new avenues of research. What other structures lie hidden in the Oort Cloud's depths? How does it interact with the wider galaxy? What more can Voyager 1 tell us before its power finally fades? The quest for knowledge is, by its very nature, never-ending. Each answer Voyager provides seems to unlock a dozen new mysteries. That is the beauty of scientific exploration. The universe is vast, and our understanding of it is constantly evolving, growing. Voyager 1 has been a key part of that growth for decades, from the stunning moons of Jupiter and Saturn, to the very nature of the interstellar medium, and now perhaps the first direct taste of the Oort Cloud. It continues to expand our cosmic horizons, to challenge our assumptions. It forces us to think bigger, to look further. The legacy of Voyager 1 and its twin Voyager 2 is immense. They have transformed planetary science, they have inspired generations, scientists, engineers, artists, dreamers.